Okay, I just want to briefly talk about the current situation right now. I know you're panicking. Let's be hopeful. Let's be hopeful. Let me just tell you what my plan is, okay? Let's go over that very quickly. So the most unknown is really about when the strike is going to end. Nobody knows. I don't know. You don't know. Nobody knows. So let's say sometime soon, hopefully after Easter. Okay, hopefully. As soon as the strike is over, we're going to follow this plan over here to finish the course. The top priority for me is to make sure you can have a smooth transition into 2030, either in the summer or in the fall. That's my top priority. It might take a little bit more time to finish the course rather than giving you a 78% exam, which I can do, but I don't think that's a good idea for you. Okay? Let's just go over the plan very quickly, which is consistent with what I said before. As soon as the strike is over, at some point, week number 1, we're going to do your lab test 2. Okay, as scheduled before. And now the only change is to save our time. I'm going to grade your lab 5 and 6 on the same week. So since I already released lab number 6 last Friday, so I do expect you to really start right away. We will have some TA hours for you. I will announce that in the same iPad note as well in the next one. Okay, and then the week after, we're going to have your lab test 3. And this one over here, I'll try to release the preparation guide for you after the Easter, so you can also start preparing. So I really don't know how long the strike is going to last. But whenever the strike is over, you can plan to say, after the strike is over, we got exactly 3 weeks of lab test, lab grading, and lab test 3. Okay? And then for the exam over here, again, after the strike, the register office is going to give us a revised dates. Our currently scheduled exam has been canceled because simply too soon. It's April 10th. There's no way you can make it to that, okay? In that case, we just have to wait. For those of you, I'm going to make also a Moodle announcement more formally tonight. For those of you who already got travel plan and cannot fix it, it's totally understandable. In that case, you have to talk to me maybe with some paperwork. What you gotta do is you gotta apply for deferral of the exam, which means rather than taking in the rescheduled dates, you may have to take it sometime in the summer, but we have to see. Okay, I gotta follow the same the formal procedure with the departments. Okay, I'll make that announcement official. Okay, so now assuming that maybe we can finish the strike within 1 or 2 weeks, so this is what I expect you to do before the strike is over. Okay, hopefully you're on the track of finishing them anyway. First of all, you have to really make sure you get prepared for lab test 2. That's the number 1 thing we'll do when we come back. And then the lab 5 background study. Notice that you're supposed to follow the videos and also PDF. From the number of views I can see, it doesn't seem to be everybody in the class who's been following that, but I don't really check who you are, but you better do it. Okay. So lab 5 is going to be covered in lab test 3 over here. It's going to be covered, which I will specify that in the preparation guide after Easter. And then you should also make sure you can complete lab 5 and 6. So that will be the 2nd week schedule for after the strike. And also make sure you also follow the lectures. Okay. And after the Easter, I'm going to give you at least a lab test 3 guide, and also eventually I'll give you the exam guide. I can tell you that the exam, most of them will be multiple choices, most of them. But it's going to cover everything we have said in the class. So you have to make sure you review all the lecture notes, all the lecture recordings if necessary, and also the tutorial videos, all the tutorial notes. That's what I can tell you. You can start preparing for your exam already. Okay? And in terms of the help, I will try to announce my office hour a little bit later, maybe tonight. But we do have tutoring hours for you. That's already announced in the Moodle, so you can check again. I'll just mention again. So we got Tuesday, Wednesday, and Thursday for the TAs. It will be from 2:30 to 3:30. It's likely to be extended for 1 more hour this week, but I'll let you know. For now, assume that it's going to be 2:30 to 3:30. It's going to be Prison Lab 106, just outside the door over there. Okay, the TA will be there. For those of you who really cannot cross the picket line, you can feel free to also follow the Moodle announcement for making a Zoom appointment completely online. Okay, and then for those of you who want to try your app on laptop or tablets, you can also drop by Williams Small Center, 106 or 108. We do have some time open up for you since 2 weeks ago. So Tuesday, Wednesday, and Friday, and also these times over here. Okay. Again, so this information is not new. It's already announced to you on the Moodle. You can check them. Okay. Okay, but as I said, for now, there's nothing you can do really to control when the step might end. I have no control either. All you can do is make sure you do what's really expected before the strike is over. That's the best preparation, because after the strike is over, we're going to go all the 3 items over here without a stop. Okay, just make sure. Okay, okay. Let's now go back to our discussion about 2-dimensional array. I would like to do 3 more examples to finish the topic, and then we'll just go over some very simple, important but a little bit simpler topics about if then else and loops, and then we'll go back to the classes and objects if we have time. Otherwise, we'll continue from next Monday. Okay, so now let's consider a new problem over here. By the way, lab number 6 is about 2-dimensional array. So hopefully if you get a chance to start, you should really be familiar with that already. And there's no tutorial videos required for lab 6. Okay, you just have to review the lecture notes for 2-dimensional array. Okay, so this is a problem. Let's say given a 2-dimensional array, let's say integers. Somehow we want to determine the shape of the 2-dimensional array. If that's a rectangle. So what do I mean by rectangle? Let's see some example over here. Okay, let's say this one over here. Let's say the A over here. Is that a rectangle? It's apparently not, right? You can see that. So how do you determine if something is a rectangle? Rectangle looks like something like this, right? So you got maybe the width, you also got the height, or the length, something like that. You got 2 dimensions over there, okay? So now on the other hand, this is a rectangle, so this should return true. It's a rectangle. And this one over here is false. It's not a rectangle. You can see that very easily visually. But now, how do you determine that programmatically? Okay, let's think about how you would do that. Okay, so now let's look at the true case over here first. So now, to be a rectangle, the only requirement we have is to make sure every row we have exactly the same number of columns. That's basically the key. For example, for row number 0, the length of this row over here is 2, right? For row number 1, the length is also 2. And for row number 2, the length is also 2 over here. So that's a rectangle. As long as you got the same length for every row, then that's a rectangle, okay? For square, we got a little bit more requirement, which we'll do in the next example. But let's worry only about rectangle here. And this one over here, let's say this one here, it should be false because you can see that even though row number 0 and row number 2, they have the same length. But for row number 1, it has length only 1, so it's not a rectangle. As long as you got one row which has different length than any others, then that's not a rectangle. Okay? So now, how can we write a Java code to really make sure return true if it's a rectangle, false otherwise? Okay, that's the question here. Okay, so apparently you need a loop because you have no idea how many rows you have in the 2-dimensional array. Let's imagine that you have a row. So the key idea is, let me show you the code and then let's discuss that. So now we assume that we have a the length will be larger than or equal to 0. Let's assume. So that's our assumption. So that means if you simply have let's say if you say A is simply just like that, so that's empty array. In that case, it's not rectangle for sure. But let's assume we don't have that case. Okay, so we assume A is not empty. Okay. So now, what about the else case over here? So now the critical step is this one here. Since we got at least one row in the 2-dimensional array, so this is the critical line. So we simply declare a variable over here called assume length. So what can that be? For example, over here, in the case of this A over here, what's the assumed length? It's going to be the length for the first row over here. And what about for this A here? The assumed length should be also the length of the first row, which is 2 for each, right? And now what should we do? What we should do later is to go on from the row number 1, the next row, to make sure its length is exactly what we assume the length should be for the rectangle. Okay? So now let's say, for example, over here, we know that the assumed length is 2. And similarly, for this case over here, the assumed length is also 2. And what we got to do is starting from row number 1, as long as we see any row whose length is not equal to 2, in that case, we know that it cannot be a rectangle. Okay, that's kind of the idea. Apparently, you can see that for this second case over here, for row number 1, the length is 2, which is equal to the 2 over here. And row number 2 is also 2, which is equal to the 2 over here. And now, for this first case over here, you can see that in row number 1, we already find the violation cases over here, right? Because the length for row number 1 is simply just 1. So A1, which is row number 1. And then the length is, in this case, just 1. And 1 is not equal to 2. So that's a violation case. Okay, that's kind of the idea. Okay, any question about the idea over here? That's how you determine if the two-dimensional array has the shape rectangle. Basically, you want to make sure every row over here has the same length. If no, they should be returning false. Okay? That's why you will see that we have a Boolean variable over here, just called it isRectangle. Initially, that will be true because we haven't found any violation test case just yet. As soon as we find a violation case, we should return false, as soon as. Okay? So now what we can do is we can say it's rectangle over here in the body of the loop, and then we just make sure we accumulate the result using conjunction. Every row must be the case, so we use conjunction. And then we simply say the length of the particular row we are talking about, right, over here, should be equal to assumed length over here. Okay? So in the slides, what you will see is we start from row number 0. You can also start from row number 1, if you like, okay, as I said. And then eventually, after you exit from the loop, you can just say, based on what isRectangle is, you can do something else. Okay? So now, okay, basically, these are the two examples I just talked about, right? So this should be true, and this should be false. Oh, sorry, the other way. So this should be false, and this should be true. Any question about the code here? Okay. It's actually rather easy because we already talked about how you can run a loop to determine some property last time. If you are still not confident, review the lecture notes from last Monday. Okay. Okay. So that's the first example to do today. Okay. The second one, yes. Questions? When you run it the first time? Yes, true, yes. Yes, so I presume your question is about this value over here, right? Oh, right? Okay, so now, the question was, you can see the initial value over here for the row is 0, right? Let's think about what's going to be the first iteration. The first iteration is going to be something like this. Let's say we say 0 over here, and let's think about the first iteration. In the first iteration, we know that row is going to be 0. Let's just substitute the value into this expression over here. Okay, it's going to be is rectangle is assigned to is rectangle. Okay, so far just replacing, just copying this like that, and also a. So row is 0. A0 dot length equals assumed length. And what's really assumed length? We know that previously assumed length is simply just A0 the length. So these two are really equal. That's right. For the very first iteration, it will just return true no matter what. That's true. It's kind of redundant, but that's okay. It's only one redundant check for the very first iteration. But starting from the second iteration, we're going to look at 1 over here, A1, A2, A3, etc. Okay? It's only the first iteration that's kind of redundant. So that's why I said over here, if you don't like, you can replace this by 1. That's also fine. Okay, maybe that answers your question, I guess. Yeah, I see what you mean. Just talk about simplification, but let's just leave it like that for now. Yeah. Huh? Yeah. Good. Okay. let's now talk about another case over here. So that's about this rectangle. Okay. Let's now go back to the slides over here. Okay. And a very simple exercise for you. Apparently, you can see that over here, every time when you try to calculate the current row, the length, you simply accumulate the result to this Boolean variable. How can I change this fragment of code such that as soon as its rectangle becomes false, which means we find the very first violation witness. In that case, we want to exit from the loop. How do we do that? Yes? Okay, if you want to answer, go ahead. Yes. As part of the, yes. Okay, let me just put it down. Okay, that's exactly correct. So hopefully you're feeling comfortable about this. Okay, so now, basically what I will do is I'll show you the solution to that. So basically you can see that the current state condition for the loop is like this. Simply say row is less than a.length, which means currently it's going to go row by row until the last one. But now we want to say that as we'll only stay in the loop when its rectangle has not been falsified yet. Okay, so what we can do is you can say is rectangle over here ampersand, okay, and also row less than a.length. So that can make it slightly more efficient, right? So for example, in this case over here, you can see for the very first iteration we are okay, but for the second iteration, it's going to make it false. That means we don't bother to go to the third row. Okay, good. Okay, let's do a slight extension to this example here, slight. So now, let's say rather than having a rectangle, let's say we have a square. Okay, square has more requirements than rectangle. For rectangle, we say that every row must have the same length. But is every rectangle also a square? Not necessarily, right? Okay, let's see some example and then you will see the idea. Okay, let's have a look at the example over here. So you can see that these two examples over here are the same as before. Okay, apparently you can it's square, so apparently this is not, so that should be false. This is not a square. Okay, it's an irregular shape. This one over here, even though it's a rectangle, but it's not really a square, is it? It's not really, right? Well, we'll think about why in just a moment. And apparently this one, the third one here, it is true. It is a square. So what's really the requirement to be a square then? Yes, go ahead. Yeah, the number of rows and the number of columns should be equal, right? Okay, good. Maybe that's what you meant to say. Yes, good. So now you can think about that. So basically we got to do a little extra step over here. Before we assume the length for every row should be the length for the very first row. That's what we did before. We just have to change this a little bit to make it check for square. We're going to assume the length for every row should be the same as the number of rows we have. Okay? So for example, over here, you can see that the number of columns over here for the first row is 3, which should be the same as the number of rows over here, right? These should match. Okay? I will make it more visual for you. First of all, let's see what's really a.length. Let's talk about the third case over here, right? The third case. A.length in this case is simply equal to 3. Okay, let me use blue over here. It's going to be 3, so that means that's 3. And now we have to make sure every row has exactly 3 elements in that particular row. In that case, you can see that for row number 1, for row number 0, it's going to be 3 elements. For row number 1, it's going to be 3 elements. And this one also 3 elements, exactly like that. Okay? So, given that apparently if any of the, as soon as you find out any violation case, you're going to return false for the other cases. Okay? Let's have a look at the code very quickly. Okay? So the code over here, you can see that basically this is what we have to change. That's a key change. You're going to say assume length is going to be a.length rather than what we did before for this rectangle a0.length. It's different. Okay, that's a key. So you should really look at these two examples together to see why we have to implement slightly differently. Okay. Okay, and then basically we do what we did before using conjunction over here, and then we just check the consistent with length on every row for the assumed length. The code itself is going to be very similar. Okay. Okay. Any questions? Okay. Hopefully that's not too difficult. Okay. So now one more. The last example for two-dimensional array, and this one over here is require quite a bit of thinking. I'll just give you some guidance on how you can think of it. Okay. Let's first of all think about what it really means. Given the two-dimensional array of integers, let's assume it's a square. Let's assume. You can be guaranteed whenever you run this method here, it's going to give you a square shape array. Okay? And now, what we want to do is we want to somehow traverse or only print out the lower left versus upper left area. What do I mean by that? I'll show you what it means. Let's look at these two square shape two-dimensional array. So what do I mean by lower left? So now let's be a little bit more conceptual over here. If you have a square like this, okay, so this over here, I call that the lower left. So how does that correspond to what the cells in the two-dimensional array? It corresponds to like this, You should really print out, for the first row, only the first elements. For the second row, the second two elements. For the third row, the first three elements. And the fourth row, the fourth elements over here. Like that. It's pretty much like lower left. That's what I mean. So that's why the assumption that the shape of the two-dimensional array must be a square is important. Okay? That's one way to, that's one case. What about upper left? Let's also draw that. Let's say I also have a square over here. Okay, upper left looks like this. Okay, it's also on the left, but it's upper. Right? So now, how do I print it out then? Okay, it's a little bit like this. Okay, let's try. So that means for the first row, you print out everything. For the second row, you print out everything except for the last. For the third row, you print out everything except for the second last and the first and the last, right? And then like that. Cool. That's like the upper left. Similarly, you can think about what it looks like for the lower right and upper right. So those are symmetric cases, which I can leave to you as exercise. Any question about the problems over here that we're trying to solve? So lower left versus upper left, first of all. Okay? So now, the next thing is, given that we understand geometrically what should be printed out, but how should we program that, given any square shape two-dimensional array? So let's look at the lower left first. That one's a little bit easier. Okay, let's think about that. Okay? So now, let's be a little bit more precise over here. So what exactly is printed out? So this cell over here is A00, 0. Okay? For row number 0. And this one over here is A10. Okay? And this one here is A11. Okay? Let's just finish that and then let's observe the patterns. So every time if you want to print out something from a two-dimensional array geometrically, the key is you want to observe what's really going to happen. Okay? And then for this one here, we got row number 2, and then we have 0, and the same row, number 2, and also 1. And also A, 2, 2, like that. Okay, let's just finish the last row. So it's going to be row number 3, and then 0 over here, and also 3, 1. And then 3, 2, and also 3, 3 over here. Okay, so these are the elements we want to print out. Okay, but how do we do that? There are many ways you can achieve this. I'll just show you one way of doing it. And the way I do it is by simply by observing the relationship between the two-dimension counters over here. Okay, so now let's look at the row counter first. It's kind of the easier one. Okay, let me use pink over here. So we can say row number 0, row number 1, and also row number 2. Okay, you can see I only highlight the row number, and also row number 3. Okay, so basically we just go between 0 and 8 length. Basically, we still go around that range. But now the trouble is, for row number 0 over here, we only print out certain columns, right? That's the thing, okay? Let's try to see what we can observe. Let's try. Let me use a different color. What about orange? For row number 0, we only print out column number 0. For row number 1, we print out two things. Column number 0, column number 1. Okay? Hopefully you will gradually observe what the pattern is. For row number 2, we print out column number 0, 1, and 2. For row number 3, 0, 1, 2, 3. Can you kind of see the pattern here? Right? So now you can see that the number of columns that we have to print out for a particular row depends on what's the value for the row counter at the moment, basically. Okay? I'll just make that conclusion there and you can think about that. Okay? So how do we program this? It's very easy. Let's look at that. You can see that over here for row counter over here is still between 0 and a.length minus 1, the same as before. But now, for the column number there, you can see that this inner loop here is really critical over here. Okay? You can see that if this inner loop is like before, as we discussed. But over here, we have the upper bound over here is less than or equal to the row counter. Right? Let's say for the very first iteration for the row number is going to be 0. So the column number is going to be 0 to 0, which is 0. And for row number 1, the counter value would be 1. In that case, the column counter should go for 0 and then 1, right? So this 1 over here is the upper bound. Upper bound for the column counter. Okay? That's basically the upper bound, right? That's why you have this over here. And then inside the body of the inner loop, we just do what we did as before. Row and column over here. Okay? Any question about this? What should we try? Why don't we try quickly? Okay? Because once you understand the lower left, the upper left is kind of similar. Okay? Just a little bit more tweak. Okay, let's try that. So now let's try that. Let me just do only row and column. Let's say row over here and column. Okay, like that. So now let's say initially row is going to be 0. And what's a.length over here? A.length is 1, 2, 3, 4. Let's just remember that for this particular example is 4. Okay, so that means we're going to go for row 0, row 1, row 2, and row 3, etc. Okay, actually only up to row 3. Let me just make some space. It's going to be row 0, row 1, row 2, and row 3. And you put it like that. Okay, so now when row number is 0 over here, let's look at the pink part over here, the second line for the inner loop. In that case, column number is going to be initially 0. That's going to be the first value. And then column must be less than or equal to the current value for row, which is 0. So 0 over here is okay. So we're going to go inside and then print out row and column. And then what do we do next? We're going to increment the value for column from 0 to 1. In that case, 1 less than or equal to 0 will be false. So we don't do it. Okay, so we exit from the loop already. And then we go to the second iteration for the outer loop, in which case the row number is now 1. Right? And then for column number, it's going to be reinitialized to be 0 again. So it's going to be 0, and then we go for 1. And then when we go to 2, it's going to make the state condition false again. Right? We're going to follow this pattern here. And then for 2 here, it's going to be 0, 1, and 2. For 3, it's going to be 0, 1, 2, 3. Okay? Okay? I'm going a little bit fast over here because we talked about the structure for nested loop many times already since the past few lectures. So hopefully you can get it. If you don't get it, you can review the lecture notes or ask me. Questions about this? Lower left. Okay? So now, the next question is, how do we do for upper left? The upper left is kind of like the opposite to what we want to do, right? You can see that over here. Let me just give you one example here. You can see that in the case where we got row number 0, right? Row number 0 and row number 0. Let me just put, just leave it empty just for now, and I'll use a different color to show you. A, 0, and then something over here, okay? So now, in this case, used to be the case that when the row number is 0, then we only print out 0 colon. But now it's kind of the opposite. When the row number is 0, we're going to print out all the rest, basically, right? So it's going to be 0, 1, 2, and 3. And what's really the upper bounds over here? It's not really the row number anymore. It should be something to do with the length of the column. Okay? So now let's be careful over here. So now 0, 1, 2, and 3. It's basically from 0, the very small value over here, until a 0 the length minus row, basically. Because the row number is currently 0. And of course, this is also row. Okay? You can verify that formula by yourself. Okay? So now, how does the code look like? Like here. Okay? So now what you will see is, we still go row from 0 until a.length minus 1. That one doesn't change. But now, what's really changed is over here, the upper bound over here. So now we want to print out more as we go for smaller row number, right? So for row, let's just try. Okay, let's try one more. So let's say we got row over here, and also we got column over here. Okay, let's say row number is 0, and then eventually also 1, and then 2, and then 3. So what's going to happen here? When row number is 0, column number will just be initialized to be 0. Okay, and what's really a row, the length, minus row. Okay, this is a bit more complicated. Let's try. Okay, over here, a row over here, let's say a row the length. Let's just make an intermediate expression to show you. What's a row the length? It's basically a0 the length. A0 the length is how long this first row is, which is 4. In which case, we're going to run the column value from 0, 1, 2, 3, and then as soon as we reach 4, we're going to exit, right? So it's going to be 0, 1, 2, and 3, in the case where row is actually 0. Okay? Let's just go to the next iteration. When we go to the second iteration for the outer loop, in that case, a row the length is what? Similar, right? It's a square shape. In that case, a1 the length will still be 4. But now be careful, because we say that it's going to be a1 the length minus row. But the row number has just been incremented, so now that means we got fewer to print out. So now that's going to be, let me just say a row the length minus row. Okay, that's a bit better. So what used to be 4 minus 0, but it's now 4 minus 1, right? So that means we got 3 values to print out. So that means we got 0, 1, and 2. As soon as we get to 3, we're going to make it false and then exit from the loop. And in the case of row being 2, it's going to be 4 minus 2. So that means we got 0 and 1. In the case of it's 3, we got 4 minus 3, and then just 0 over here. Okay? Yeah, so it's kind of difficult for you to really understand completely just by following this. But I would suggest try to trace it by yourself as well on the paper. Right? That's really the best way to learn. I'm just trying to give you some guidance. Any questions before I move on? Yes? You mean the array contents? Okay, so the question was, what if the array has null values? So first of all, if you look at the problem itself, let's have a look. Okay. We say that we're given a 2-dimensional array of integers. So when we talk about integer values, there's no null values. Null values are only for objects, which will go back maybe next week. But let's just very briefly. So when you talk about integer array, so the default values is 0, right? So now, if you look at the array over here, you can see that you're right, maybe that it's that everything is 0. But that's okay, because the main thing about this problem over here is print out which positions of the 2-dimensional array. It doesn't matter what values they are stored in the array. Doesn't matter. It can be all zeros, it can be all ones, or it can be different values. Okay. Okay. So now, what will be the output? Let's just say, since you asked this question, let me make it more precise for you. Okay. So now we know that. Let's just have some hypothetical value over here. Okay, let me just just erase this for now, and I'll give you one example printout. You can also try on Android Studio. Okay, let me put some value here. Let's say we got 43, 4, 3, 2, 1, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Let's say that's a two-dimensional array we're given, let's say, okay? So now what exactly will be printed out? Let's say for the upper left. For the upper left, it's going to be like this. Conceptually, it's like this. For the first row, we do print out everything over here. For the second row, 0, 1, and 2. For the third row, 0 and 1, and then 4, right? You can see there's a print line at the end. So which means separate each row output by a new line, right? So what will be printed out? It will be like this. It would be 4, so this will be the output. It will be 4, 3, 8, 12, and then the second row will be 1, 2, and 9, and then 3, 6, and then 4. So that's the printout. Okay. Any other questions for this? Okay. It's a tricky one, but the main thing is just to show you how you can play around with the state condition for your two-dimensional array loops. Okay, what about exercises? How do you do upper right and lower right? Okay, let's think about it. Okay, I'll give you conceptual hints. Upper right and lower right. Let's have a look. That will be exercise for you. Think about it. It's actually not too bad, not too hard. Okay. Let's say you have a two-dimensional array like that. That's a square. Okay, you can always assume that. Okay, so first let's talk about upper right. And also we have lower right. Upper right is going to look like this. Upper right is going to be something like this. You only print out this area right here. Oh, that's lower right. Upper right is going to be like this. Conceptually. But how would you do that? It seems like for the very first row, you still print out, everything. But for the second row, you print out everything except for this first column, right? And for the third row, you print out everything except for the first two columns, and etc. That's kind of the hint for you, okay? What about lower right? For lower right, it's going to be symmetric. Something like this. Lower right, like that. Okay? Think about these two exercises. Think about them. Okay? Any other questions about the two-dimensional array? Okay, if you have no questions, then what I will do is I will go. So that's your exercise for the lab number 6. Hopefully you have seen this picture already. If you haven't, you better start. Okay, we'll mark that on the second week after the strike. You have some time, but you better start. Okay. Any other questions before I move on to a new topic for if statements? Okay, are we okay? Yeah. Okay, let me just start the selections lecture again, and let's do something tricky. Okay, let's go back to the selections lecture, and then let's do it. Okay, so I would like to start with something simple first, and then we'll go to something tricky. Okay. Full screen mode. Okay, let's just wait for the full screen mode. Okay, so now, there's some common error over here I would like to remind you about when you do the if statements. Okay, let's try to look at that. So this is what you should know. So somehow brackets can be omitted if you have only one statement for your if statements. So what do I mean? Let's have a look at this. If you look at the code over here, okay, which I do have on my iPad, I'll show you over there. Okay, I will do that in just a moment. Okay, over here. I want you to look at, these 3 lines are something we have done before. I want you to look at this if statement here. We say that if the radius we read from the user is larger than or equal to 0, then we're going to print out the area is whatever this, okay? You can see that there's no brackets around this statement over here, okay? Now the question is, would it work as expected? That's the question. The answer is yes, okay? Even though we have no brackets, okay? The reason is, in Java or in the C family language, so if you have only one statement, only one single line of statements as the body for the if statements, in that case, you don't have to put the brackets. So if you put something like this, it's as if you put something like this. That's how the computer will understand it, okay? So this fragment of code and this fragment of code, they are completely equivalent, okay? So that's something I want to say first, okay? Any question first about this general description here? And I will show you what can go wrong in practice. Okay, so the general description is about if you have only one single line as the body for the if statements, then you can omit the brackets. But sometimes you might make a mistake like this. Let's consider something very similar over here, which I do have in my iPad, okay? It's a bit bigger. Let's look at that. So now, according to the indentation we have over here, so what do we intend to do? And what we want to show is what you intend to do may not be exactly what the computer would do for you. Okay, that's the trouble. Okay, so now again you can see that something we have a pi and also input reading the radius, and then we want to calculate the area. And now we say that if the radius is larger than or equal to 0, according to the indentation, we want to do 2 things over here. 2 things. We want to, first of all, if the radius is larger than or equal to 0, we're going to calculate the area, and also we're going to print out what the area is accordingly. Okay? So now I have a question for you. Given what I just said in the previous general description, let's try the following input. Okay? Let's say input over here, right? I'm going to read in some radius. If I read in something like this, let's say -2. What's going to be the result if I say -2? Do you think it will give me -2 multiply -2 multiply, let's say 3.14, whatever the pi is, first of all? Is it going to display this result, or it's going to display something else? It's going to display 0. How come? Only the first sentence. Yes. Okay. Very good. Okay. So guys, let's look at this example over here. It's very typical. Okay. Apparently, the indentation here suggests what we as a programmer we wanted to achieve, but that's not how the computer will read it. As I said before, the computer will actually read your program like this. It's going to somehow put the brackets along the first line only. So this is going to be treated as the body for the if statements only this one here. And the second line over there is treated as outside, like that, outside the if statements. So now this program over here, what's that going to be equivalent to? So this is really equivalent to when we say if radius larger than or equal to 0, if you put the brackets over here, and then it's going to say area is assigned to whatever expression it is, and then you will print out, and then the area. So that's how the computer will read it. So if you try -2, because -2 larger than or equal to 0 is going to be false, so you're going to print out the area of the default value directly, which is 0 over here, without doing any computation. Okay? Any question about this? So what do you learn from this? What you learn is if you have more than one line that's intended to be the body of the if statements, you better put some brackets. Simply putting the indentation over here to be the same, it's not going to force the computer to do what you intend to do. Okay? You really want to put the brackets. Okay, so let's go back to the slides over here. If you look at the slides over here, so what you're going to do is you put the brackets over here. Okay? Yeah. If you don't use brackets, no, it doesn't really matter. So brackets are there to force the computer to read in a particular way. Without the brackets, in this case, the computer is going to read it the wrong way. So you really want to use brackets. Nothing to do with efficiency. Yeah.
I wonder how exactly, like, because here, like, with no braces in that if statement, I wonder how, is there like error message that will be produced when we run the code?
No, in this case, no. Because let's only talk about this particular code over here. Let's have a look at that. So let's say this case over here, let's say the brackets was not there. Okay, let me just get rid of them for now. If the bracket was not there, right, it's the computer somehow, when they read your program, they're going to do some processing of your program. And when they do the processing, they're going to put the brackets for you conceptually. So this is how they're going to put it. They would say, since the programmer didn't put any brackets over here, so that means the first line over here must be the only body of code for this if statement here. And the second line over here does not belong to the if statements. That's how the computer is going to understand it. Okay? That's why I said you better put it if you really mean to put something there, right? So that's why if you look at the fix over here, we'll actually put the brackets around the two lines over here. Okay? Guys, any questions about this? Okay? It's kind of tricky and boring, but I just want to go over them because you might make some mistake like this. Okay? Be careful. Okay? Okay, if no questions, then let's go to the next one. Okay, this one is also very, very tricky. Okay? So now, I'll just show you the code directly. Okay? Let's have a look at this block of code. My question for you is like this. What if the radius value over here is -2? Okay? If it is -2, what's going to be the output? Oh, actually, you know what? Let me just not do -2. Let me just do something that's more normal first. Okay? Let's say we got the radius, what about 3? Let's try different values over here. If we got 3 versus -2. Okay? Let's try that first. Okay? What about the case for 3? So you said you will not put anything, right? What about -2? You will also wouldn't put anything? Okay, let's think about what's really the intention over here. The intention for this code seems to be, we want to say we only do calculation and print out when the radius is larger than or equal to 0. That's what we intend to do. Which means, for the case of 3, we should do something and print it out. And in the case of -2, we shouldn't do anything. That's what our intention is. Okay? I can tell you that for this particular code, in the case of 3, what it will do is, it's going to calculate the area accordingly, yes. It's going to return 3 times 3 and then times pi. That's fine. However, in the case of -2, it's also going to print out the following. It's also going to print out -2 times -2 times pi. That's not good. That's not what we intend to do. And why? Do you see anything you're going to have a sharp eye for this example here? There's a semicolon there, right? Where? There's a semicolon over here. And I've seen this quite many, well, maybe you're not making such mistake anymore beyond left has 1, but maybe you did it before, okay? So if you put a semicolon there, what does that mean? That means the if statement here is standalone by itself, only up to there. And then these two lines are completely separate from the if statements. So if you do that, this is equivalent to the following. I'll rewrite it. So if you write that, it will be equivalent to this. If radius larger than or equal to 0, and then do nothing there. Just do nothing. Because you just put semicolon to means terminate the if statement here right away. Don't do anything. And then after that, you will just do, no matter what, just do area is assigned to something and then print out the area. Okay, this is what this program is equivalent to. Okay, so be careful. Okay, of course, this semicolon here, I don't think that's what's really intended to be put here, but you might put it just by typo. So get rid of it. Okay, it's also a common mistake. Okay. Okay. Yes. So say it again. Over here, you know what? I see what you mean. So somehow I'm not really trying to give you a complete code fragment over here. I'm just discussing only this particular box. If there's nothing before the semicolon there, oh, you know what? It simply means nothing's changed over here. You just do nothing there. So there will be no complaint. Yeah, compiler will be okay with that. Yeah, so basically it's this line over here is basically say this line here. We check some condition there, either that's true or false, we'll simply just, thank you. So basically this line over here, okay, with a semicolon is equivalent to this line over here. So what does that mean? That means we have some condition to check, whether that's true or false, we just do nothing. Just nothing. Yeah. Okay. Okay, good. So now, let's now do something that's a little bit tricky. So that's something I would like to spend a little bit good amount of time today. Okay. So now, overlapping Boolean conditions. Okay. Now, let's go over just some very simple terminology here. So we want to talk about whenever you got Boolean conditions, sometimes when you put your if, else if conditions, you have to somehow sort your Boolean condition in a particular way. If you haven't sorted that way, you're going to run into trouble. Okay, I'm going to show you that. Okay, let's just go over some terminology very quickly. It's very easy to understand. Let's use an example. First of all, we say that two Boolean conditions overlap if they can evaluate to true simultaneously. So what do I mean by that? Let's try. So now, let's say we have a variable called marks for the lab test, for example, the marks. Okay. Now, let's consider two Boolean conditions. Marks larger than or equal to 80 versus marks larger than or equal to 70. Okay? I'll put that on the iPad as well. Just give me a moment, and then we'll talk about it. Larger than or equal to 80 and 70, right? Okay, so now we got these two Boolean conditions here. Depending on what marks is, it's going to give you true or false, right? Depends. But now, we say that these two Boolean conditions, they overlap because there are certain values which can make these two Boolean conditions true at the same time. Just give me one example. 81? Good. 81. Good. 81 is going to make both true at the same time. Can you give me one value which is going to make one true but not the other? 75, yes, 75 or something like that, right? 75 is going to make this true, but not this one here, right? So now, can you say something like, let me call this 1, and let me call this 2. Out of these two conditions here, can you make a more general assertion as follows? Satisfying one condition guarantees you satisfy another one. So you're saying that if you satisfy 2, given that, it's guaranteed you will satisfy 1. That's what you're saying, right? For those of you who took 1019 or 1090, so this is an implication relation over here. But for those of you who didn't take it, don't panic. I'm going to give you some intuition over here. Okay? So now in this case, we're saying that every time if you got any value which is going to make number 2 true, is also going to make number 1 true at the same time, but not vice versa. Okay? Oh, yes, sir. Should I say it again? Okay, I think I make some mistake over here. Okay, can we rewind a little bit? If you're watching the recording, rewind what I said in the past minutes. Okay, so now let's do this. What I meant to say is 1 implies 2, right? Okay, let's be careful here. 1 implies 2. So we say that the condition over here, this one here, okay? We say that this condition over here is more specific. And for those of you who took 1019, you will say this is stronger. But we just should say specific. That may be a little bit more sensible, intuitively. And in the case of this expression over here, it's more general. And if you took 1019 before, it's called weaker. Okay? So if you can satisfy something specific, that guarantees you can satisfy something that's more general. Okay? Let's try to make it more visual for you. Let's try. Okay? Let's now think about in the following way. Let's say I draw a set over here. Let's say these are the set of values that's going to be satisfied by number 1 over here. Okay? Let's try. It's going to be 80, 81, 82, 83, 84, etc. Okay? And now, how do I draw the corresponding set for a more general or weaker Boolean condition? Do I draw a bigger circle or smaller circle? Bigger one, right? Let's try. Okay, let's try. Okay. So now in that case, it's basically a bigger circle over here. So now, what should I put outside the blue circle over there? Give me one value. 72? Yes, I agree. 72, because 72 does not satisfy larger than or equal to 80, right? Or 73, and etc. Okay? So now, so that means if you can satisfy this blue set over here, you also satisfy this at the same time. Okay? So we say that one is specific, the other one is more general. Yes, questions? Yeah. It's a good question. So the question was, can you avoid overlapping in the if statements? I would say in general, it really depends on what you need. But I would say in general, you may not want to have overlapping conditions. That's why I will show you some example why you don't want to. Yeah, so you're talking about sorting of the conditions, which we'll talk about. We'll get to it. Okay, so guys, this slide here is a bit abstract, but I think the main thing for you to pick up is whenever you are considering your if conditions, you might find that one condition is more specific than the other. Okay, in which case you have to be careful which one to put first. Okay, that's a caveat for you. But let's try examples. Okay, let me just go back to the slides and then let's try. Okay, so for these you can just read them through. Okay, it's about exactly what I said before. Okay. Okay, let's now do another one for you. Okay, do me a favor. We got two conditions over here: x larger than or equal to 5 and x larger than or equal to 0. Which one is more specific? Yes. Oh, okay. Which one? Larger than or equal to 5 because you got fewer value to be satisfied. And give me one value which can satisfy the more general one, but not the more specific one. Give me one value. 4, exactly. 4, 3, 2, 1, 0. Okay, so these are the ones. Very good. Okay, let's try the following example. That will lead us to, you got to be careful with the following order. Let's try this. The first fragment of code, let me see if I got them in the, no, not here. Let's try the first fragment. We put the more specific condition first. And in the else if, we put a more general one. So the way we sort the two conditions is the specific one and the more general one. Only two. Okay? Let's consider another one over here. And the other one, we swap the order of the two conditions. In this case, we do the more general one, and then we do the more specific one. Okay? So now, can you, question number 1, are these two programs going to behave the same at the runtime? Okay? If no, can you give me one example where they will behave differently? Okay? How about I'll give you 20 seconds to think about. So we already agree. So these two programs will behave differently because the way you sort the conditions are different. One goes with the more general followed by more specific. The other one just the other way. So now give me one value which is going to demonstrate a difference. I'll just wait a bit. Wait a bit. I want you to think about it, okay? Anyone want to try? I want to find some new guy. I know you have been always keen to give the answer. Anybody else? If no, that will point you. Anybody from here, from this area? No? One value. 4. Let's try number 4. If you give 4, in that case, for the first program, it's going to do what? If you do 4 over here, 6, you change your mind. Okay, so let's say 6. Okay, if I do 6 over here, so now 6 is going to satisfy both Boolean conditions. Don't you agree? All right. So we choose a value that is going to satisfy both conditions. Okay. So 6. In that case, 6 larger than or equal to 5 is going to print it out. You would say x larger than or equal to 5, right? But now you can see that for the second program there, is it going to also print out x larger than or equal to 5? No, because 6 larger than or equal to 0 is also true, right? So that means we'll print out the statements associated with the general condition, right? So you can see that depending on how you associate how you sort the conditions, the output can be different. That's the purpose for this example here. But what should be the general guidance for this? We'll see another example to see. Okay. Okay, that's exactly what. So you said 6. I just put 5. It's similar example. Okay, we just got different outputs from the program. Okay, but I would say over here, the second program over here is not really good, right? Because somehow, when you, let's say, back to your example, if I got 6, I want to really take the specific action for 6. But what you would do in this case will be, you only say x is larger than or equal to 0. That's too general, right? You want to be as specific as possible, the action, okay? So now, there is a so-called not specific enough problem. I just made up the name, but that's kind of a small example to show you, right? If you put different orders for the conditions, it can give you different outputs, okay? Let's do one more example over here. I'll come back to this one in just a moment. Let's look at this. This one over here, I want you to look at. Rather than having 2 conditions over here, I got many. I got 1, 2, 3, 4 conditions, right? So now, answer the following first. Am I trying to sort the conditions over here from specific to general or general to specific? General to specific. How do you tell? For example, larger than or equal to 2.5 is more general than larger than or equal to 3.5, right? For example, if you got 1.5, in which case it will satisfy, if you got 2.9, right? In that case, 2.9 will satisfy larger than or equal to 2.5, but it wouldn't satisfy the other one, right? So now in this case, we are sorting from the most general to the most specific. The title also suggests that's the case. But now, can we have any trouble over here? Can we? Since we talk about GPA, right? So what if I got a GPA, let's say 8.9? Would it give me high distinction? No, you only say I pass. You wouldn't say I got high distinction, right? So it's not being specific enough. Okay, that's something for you to see. Similarly, if you got a GPA, let's say 2.9, in that case, let's say if you, yeah. Okay, let's just use the high distinction. That's the main troublesome example over here. Let's say you got 4.8 or 8.9. It's simply just going to not print out high distinction, Okay, so now how do we resolve them? So now that's why I talk about the notion between being specific and being general. Okay, so in this case, you notice that this has some logical error because this will compile, no problem. The Android Studio is not going to tell you what the problem is. It's a logical error. So now the way we sort them out is by going from the most specific to most general. Okay, good. Okay, good. And that's what we'll do. Sort them, and that's what you will get. Okay? So we go from 4.5, and then 4, and 3.5, and 2.5, right? Okay. So again, I just try to give you some intuition. You should always go from most specific to most general when you got if conditions. Okay, good. Okay, now one more example over here. Let me just go move to iPad over here. Okay, now, since we also talk about overlapping, so what can be problematic when you have overlapping conditions over here? Okay, let's consider the marks. Let's consider what about 89? Okay, and then let's say this is one slide where I got if, and else. Okay, let's see another slide over here. So over here you can see exactly the same. Sorry. So guys, sorry, it's my mistake. Did I include that properly? No. What I want to show you is this. Let's look at it from the slides. This is what I have on the left-hand side. I got if, and else. Okay, that's what I have. And on the right-hand side, I got if, and else. Okay, so these two words are the only thing that's different, else and else. But the conditions are exactly the same. Okay, so now, left or right to your side, left or right has a logical error. How come? Why the left? Exactly, it's because you can see that the if conditions over here, marks larger than or equal to 80, marks larger than or equal to 70, they are overlapping, right? So that means on the left-hand side, how many if statements do we have? How many independent if statements? 3, exactly, we got 3. Let me just go back to iPad and show you. That's exactly how I highlighted. So the first one is here, second one here, and the third one is here, right? We got 3. So that means, let's say we got 89 here. 89 larger than or equal to 80, true, print out A. And we are done with that if statements. And then this one is simply another independent if statements. And then we got 89 larger than or equal to 70, also true. We also print out B. So that means we'll print out A, B, C. Okay? That's what you would do. So how do we fix this? We want to make sure when you got 89, you just wanted to print out A. What you would do is, like what's shown on the right-hand side over here. So you put else if over here. Because as soon as you satisfy the most specific condition there, you're going to stop, right? Okay. Guys, any questions about this? Yes.
You just print up A. Couldn't we like also include like another statement in like saying like it's like isn't like we can add like 90 or something is less than or equal to the marks, less than or equal to 80 for example.
Oh yeah, for sure. I'm just saying for this particular example, I'm just trying to show you, even though the two fragments are on the left and the right, they look so similar, but just like else, you know, the additional words different, you can make it behave differently, right? Yeah. Okay. Okay, that's about it. Let's try go further. Okay, this one we have talked about it. Okay, we should sort it. Okay, this one here is very easy. Basically, just to say, if you miss the else part over here, you have sorted out, and also you miss the else part, make sure you have a default value. Otherwise, let's say this program over here, let's see if I have that in my iPad. No, I don't, that's fine. So now in this program here, can you see any logical error over here? Apparently we have a missing else statements over here. So now what happens if I got what? Give me one example that's going to show some weird result. How about 8.9? Will 8.9 work in this case? It will work. So give me one value that wouldn't work. Okay. 1, for example, if you got 1, That means none of the condition will be satisfied. In that case, we only get a default value of the empty string. Okay? So now there are two ways to fix this. There are two ways. Either you can simply put, for example, f over here as a default value. That's one way to do it. Or you can add else statements, either way. So the expression, the one I show you over here is to put an else statement over here. Okay? You can just put an else and say else fell. Okay? And you can also, there's a hyperlink over here. If you look at the previous slide, I'll show you briefly. In the previous example over there, many slides ago, in that case, we simply put f as a default value. That's a second fix. You put a default value here, and then you can safely ignore the else statements. So it's just a different style. Okay? You can feel free to use any one of them. Okay? Okay. Okay, that's good. So let's go back here. Okay, this one here is also interesting. Interesting. Question for you. What if x is 20? Is it going to print out anything? I heard no, which is okay, because somehow, let me just say something which is misleading to you. Somehow, according to the indentation we have over here, it seems like the else statements over here is part of the if, right? If else. And also, inside the if, we have just another if, no else, right? According to the indentation, that's the case. However, that's misleading. One thing you have to realize as a programmer is what you think might work may not be the case, interpreted by the computer. Okay? According to the indentation here, we have if statements and also else, and also inside the if, we just got another if. So if we simply replace 20 over here for x, 20 larger than or equal to 0, true, right? And then we'll go for the if statement over here, and then 20 larger than 100. Which is false. That means we go to the else part, but there's no else part, so print nothing. That's what you would think. So for those of you who said no, it's reasonable. Okay? But the answer is no. It's going to print out something. It will print out x is negative. That's what you would do. Okay? So now, this comes to a little bit like something called parsing. So this is more like a word for, so whenever you say a computer is going to read your program, we say that the computer is trying to parse your program. So whenever they try to parse your program, they got to determine what exactly your program is supposed to mean. Okay? In this case, I can tell you how your computer is going to parse your program. Okay? Let's try that. Okay? Okay, according to what you wrote over here, okay, this is basically what you mean. If x larger than or equal to 0 over here, and then we say if x larger than 100 over here, okay, and so we got a print line over here, I'll just put a line here. And then the else part, that's really the issue over here. You as a programmer, you thought that else, according to the indentation, should belong to this if. No, that's not the case. The computer, the way the computer reads it is, it's going to think that else is part of the inner if over here. And that's it. That's how the computer reads that. So this is something called a parsing rule, okay? Parsing rule for the computer. For those of you who are interested in exploring this further, you can take the upper level, maybe compiler course later, but let's not worry about it. I just want to show you one example to show you that whenever you got if and if, also you get an else, you got to be careful because how the computer is going to bracket them is going to be like this. It's going to find out if you see the else over here, it should correspond to the latest if over here, which is the inner if. Okay, that's how the computer is going to read it. Okay, and now the question is, how can we fix it? Whenever you want to force the computer to read something in a particular way, you got to use brackets. So how do we use brackets? Okay, let's try. Okay, how do we fix it? The way you fix it is like this. You want to say if x larger than or equal to 0, I want to force the computer to treat whatever is inside the brackets to be its body. And then I would say else over here. And then else I would say print line, x is negative. Okay? And then inside the if body over here, I can do, oops, thank you. Sorry about that. Okay. Okay, you can see the if and else over here. So the main thing is really about adding the brackets over here. That's the main point for this example. Okay? And then inside the if, what should we do? Inside the if, we should simply do another if over here. If x larger than 100, and then we do whatever that's there. Okay? So the difference between these two versions over here is really about the brackets over here. That's really about it. Okay? Just one example. Okay. Let me just move to there. Guys, any questions? So in the final exam, we'll only test you something I taught in the class. So just make sure you understand this one. That'll be enough. There are many other parsing rules, which we'll teach you maybe a little bit later in 2030. But for this course, this is just one of the few. Okay? Okay. Any questions before I move on? We're good, right? Good. Okay, good. And then what I want to do is, let's go back to the slides over here. Let's see anything else. So that's how you fix it, just adding the brackets here. Okay, I want to talk about one more thing, and then I will go back to classes and objects. Okay, maybe two more things, two more. So this might be the code you will write, usually, right, in your lab. Okay, basically we have a Boolean variable here, it's even, and then we say that some number variable, if modulo 2 is equal to 0, then we assign is even to be true. Otherwise, assign it to be false, right? This code is absolutely okay. Nothing wrong with that, okay? But now, I want to show you, I want to somehow help you to simplify that a little bit. How can we simplify that? You can see over here, you have a one line over here for declaration. You got also separate lines for the if statements, right? We want to simplify this into a single line, okay? You want to say the answer? Oh yeah, for sure, yeah, absolutely, yeah. Okay, so let's try to, I'll give you the answer first, and then let's think about why you can derive that simplified expression. Let's try. I would say this over here is absolutely okay. I'm just saying that for you as a beginner, that's absolutely okay. But let's try to learn a little bit more advanced, okay? Let's try. Jordan, right? That's what you just mentioned, yeah. As Jordan suggested, let's try. So basically, you can simplify this into is even over here is assigned to. We know that whatever you put over here should be a Boolean expression. Okay, now the Boolean expression there can be either true or false. And the true there is going to be like that. Right? You can simply put number modulo 2 equals 0, which can be either true or false. Okay? So the insight into this simplification is really like this. If you look at it, let's call this version 1. This is version 2. We are trying to simplify by reducing one step only. Okay, let's see that. In version number 1, think about how the computer will work. You try to put a box over here is even, right? So this is a box called is even. And then you try to really evaluate this expression over here. You try to do that. And this expression somehow under the hood is going to put in some intermediate box. No name. Okay? It's going to store number modulo 2 is equal to 0 somewhere. Okay? And then what you will do is you will check to see if the box contains true. In that case, assign is even to true. If the box contains false, then we assign that to false. That's basically what we do in the version number 1. So what the simplification we're trying to do over here is basically to say, let's not worry about the box over here. Why don't we just put the expression directly on the right-hand side? Okay? So whatever you should set this is even into depends on just the box over here. Put it directly here. Okay? That's kind of the picture. Okay? Little exercise for you. Little exercise. You mean version 1 looks simpler to you? You know, actually, I wouldn't argue, to be honest, it's only a matter of preference. That's why I wouldn't say it's error. Maybe for the more advanced, maybe you can tell me in 3 years' time. Let's say you get more advanced once you get to 3rd year. If you still think the version 1 is simpler, that's okay. Yeah, let's let the time to prove it. How about that? Okay. But I would say version 1, version 2, they're absolutely equivalent. Which one you use, I don't care. Okay? I just want to show you. If you want to simplify, that's how you simplify. Let's do one very simple exercise over here. So now, let me just do it over here. Okay? Let me change the example just a little bit. Let's say this. Let's say it's odd rather than it's even. Okay, sorry. Boolean is odd. Okay? And we'll say if number modulo 2 is equal to 0, in which case we know that it's even number, right? So that shouldn't be an odd number. So we say it's odd, it's assigned to false. Otherwise, is odd, it's assigned to true. That's version number 1. Okay, again, it's absolutely okay. But now, let me ask you this. What if I try the following simplification? If I say, can I simply simplify this into this line? Is odd is assigned to number modulo 2 equals 0. No, right? Apparently not. Agree? Well, let's just verify why it cannot be the case, right? Let's try that. Let's say number over here is, let's say 3, for example, right? In that case, 3 modulo 2 is 1. 1 is not equal to 0. So that means it's going to be false, but it should be true rather than false, right? So it's not working. I would say I can only change one character over here to make it work. 0 to 1, that's one. Okay, you know what? That's one way to do it, yes. So what you suggested was simply change this to 1, right? That's one way. What about I want to change the operator? We don't change the numbers. Aha, exactly. So that's how you do it. Okay, this is not working. So how do we fix? Fix number 1. Let me just put all the fix. Fix number 1. You can say it's odd. It's assigned to, I'll say num modulo 2 equals 1. That's absolutely fine. Okay. Fix number 2. You can say it's odd. Is assigned to. It is not the case that it's an even number. Okay. Let's do something a little bit more different. A variance. Fix number 3 over here is odd. Number modulo 2 is not equal to 0. That will also work. Okay, so all the 3 work. Again, which version to use? I would say there's no right or wrong. It's really about which one. As I get more advanced in Java program, I might find the version 2 to be more precise, right? To be more concise, not precise. Okay. Okay, guys, any questions? Okay, you okay, right? Okay, so now let's go a little bit further here. So this one here is basically like a partial solution to your lab number 2, partial. Okay, so remember lab number 2, we calculate your income tax, right? So now I just want to tell you about when you actually try to do if statements, you may have repeated code, in which case we say that your code smells. So I actually mentioned about this term in the tutorial video. This is maybe the first time you see the written form for this kind of definition. So basically, when you try to do coding, you want to avoid or try to minimize repetition. Let's say over here, this code over here will work. We say that status is equal to 1, like a single status. And then we just got different cutoff points over there. And for each individual branch over there, we say that if the income is less than or equal to the first cutoff points, in which case we have part 1 only. And if we got higher income, then we got 2 parts. And then we also got 3 parts, right? You can notice that the part 1 over here is local to this particular if branch, right? And also the part 1 and part 2, they're only local to this else if. And also part 1, part 2, part 3 over here, only local to else. Okay? But in some way, we are really duplicating the code a little bit, right? But we can simplify this a bit. So what do you declare outside? Yep, you may do that. So you can see that in this case, we have local variables part 1 duplicating 1, 2, 3 three times. Also we got, yeah. Reassign it, yeah. So, yeah, exactly. So one way to fix it would be, you can try to declare part 1, part 2, and part 3 outside with some initial value, let's say 0, and then depending on which branch you are, you can reassign them to different values, right? That's one way to do it. Okay, that's how you can do it. Okay. Any one of you actually saw this code before? This code was actually posted even before Lab 2 was due. Well, okay, if you didn't notice that, that's okay. It's already passed. Right. Okay, that's about how you can, that's one case study for you to reduce the code repetition. Okay? Okay. Okay, so over here, scope of variables, we talked about the scope for variables already. So for the last part, I will leave them to you. They're very simple to follow. Okay, nothing new here. Okay, what I want to do is I want to talk about one more small topic for classes and objects. Okay, and then we're done for today. So now we're completely done with the selections lecture, everything. Okay, except for the last part about scope of variables, which you can just follow by yourself. Nothing difficult there. And let me just mention one more thing. If you go to the loops lecture, there are also additional things which I would like you to go over as well. They're also very simple. Okay? We covered all the complicated stuff already. So where we were from last time was we talked about how you can do nested loop. Okay, let me just go there quickly. Okay? So now if you try to recall what we did for the loops lecture, so this is where we left off from last time when we talked about finding duplicates for the code. So now over here, so we just talk about more common errors and some case study for the loops. So these are nothing complicated, so I'll just leave them to you. Okay? Okay, only a few examples there. You can just follow through. Okay? I'll leave them to you. So now I would like to go back to the classes and object lecture. And then I'll talk about one topic only, aliasing. And then we continue from here after the Easter holiday. Okay? So I believe there's a class on Monday, so make sure you come. Okay? Okay? Let's go back to this example over here, alias. So in some way, this shouldn't be anything new, because I believe if you follow through the tutorial videos for lab number 4, which I believe most of you did, in that case, you have seen the alias example already. But let's just try to repeat again. Okay? I think repetition is nice for you to have a deeper understanding. Okay? So now I want you to look at this. Aliasing. Now, let's consider two very similar examples over here. They look almost the same, but the difference is we got two different types for the variables. Okay, let me just go over the structure for the example very quickly, and then we'll see why they're different. Okay, okay, you can see that over here we got integer. Okay, it's a quick review. In Java, we got two kinds of types. We have primitive types. So we got integer. We have float. Let's int. You can refer to the elementary programming lecture. Short, long. We have float, we have double, we have Boolean, and also we have character. Okay, so these are the primitive. Okay, and also we got something called reference type. So reference type, basically everything that's not primitive is a reference type. That's how you can understand it. Okay, so every time when you talk about a type, if you refer to some class name, that's a reference type. For example, string is the most commonly confused one. String is not a primitive type, it's a reference type, because you can see that it's capitalized. Okay? And also we have maybe point, or you can have person, or game, etc. Right? Every time you refer to a class, is a reference type. Let's just get it clear. Okay? So now, let's go back to the two examples over here. Let's just go over that. Line number 1, I is assigned to 3, integer. And then integer j is assigned to I. And then you want to print it out. I is assigned equal to j. Line number 2, let's just go over everything first, and then we'll see how they will behave differently. Okay, and then you will just do some reassignments over here, and then we do another code. Let's say we define a class called point, which we did before, right? Class point, and then we got x, y as attributes. And then we do something very similar. When we say point p1 is assigned to new points, and then we say p2 is assigned to p1, okay? Pretty much like a j is assigned to I. And then we try to print out p1 is equal to p2. Let's only talk about equals today, only that, okay? So now, let's try to understand exactly how this is going to work, okay? So now let me go back to iPad here. So when you say I is assigned to 3, what's going to happen? When you say I is assigned to 3, that means you have a placeholder over here called I assigned to 3. Okay? Oops, sorry, like that. Okay. Okay, and then second line, when you say j is assigned to I, what do we do over here? Basically, we copy whatever that's stored in I into j, right? What you will do is like this. When you say j is assigned to I, you're going to make a copy of this and put it in here. It's j. So the 3 here and the 3 here, they're independent value. They're separate copies, okay, of the same value. Okay? Okay, when you say print out I is equal to j, true. Very good. Right? 3 is equal to 3. Nothing special about it. And now, let's say we got another value over here. K is assigned to 3. So what does it do? So k over here is assigned to 3, just like that. Okay? And then, when you say k is equal to I and k is equal to j, well, they're all the same, right? It's also going to be true. Because you can see what we have created, we got 3 copies of the same value over here, I, j, and k. They're all the same. Okay? When you say equals. So for example, when you say j equals k, you're already comparing these two values. Okay? That's about comparing primitive values. Okay? Just use equal. So now, let's make things a little bit similar, but in a different context. Let's try that. Okay? Let's review a little bit. I'm going to review more on Monday. Okay? Let's try to review this part here. When we say point P1 is assigned to new point 2, 3. Okay? Okay, let me just put it here. Remember, let's just recall. We have a class called point. And then we have, let's say, double x, double y. And then we also got the point constructor over here. And then we have double x, double y. And over here we can say this dot x is assigned to x, and this dot y is assigned to y. Okay, that's what we have. That's it for the class. Okay? So now, what does this line do? Line number 1. Yes? Yeah. Oh, yeah. So I'm going to review this maybe next time, but let's do very briefly. Over here, you can see that we got this keyword over here. So whenever you see this keyword, that refers to the attribute. So this dot x is referring to x, yes. On the other hand, the x over here on the right-hand side is referring to the parameter. Okay, I will review this maybe Monday. Okay, next Monday. Okay, given this, let's try the following. Okay. The first line here, when we say point P1 is assigned to new point 2, 3. So before we talk, well, maybe many weeks ago, so we talk about how you can visualize this, right? Let's review very quickly. Okay. So basically, we're going on the right-hand side, we're going to create a new object on the memory, with attribute value x being 2 and y value being 3, and then store the address of that new object into this placeholder called P1. Okay? So what does that mean? Let's try. Basically, what that does is, let me also copy the line over here. Point P1 is assigned to new point 2, 3. Okay, let's see what that does. Okay, what it does is the right-hand side over here, we're creating. Let's say this is the memory. Let's say that's a computer memory. Okay, and then we're basically creating a new object over here somewhere, allocating the space and create an object over here, and the object is of type points. And we know that for every point object, you got x and y, so that means we got x and y over here. Okay, in this particular case, we got 2 and 3, right? So that means we got 2 and 3 over here. Okay, that's what the right-hand side would do. Okay, if you have doubts about this, you should review the previous lecture on how we can visualize the creation of objects. And now, what do we really store in P1 over here? That's the critical thing, right? We know that P1 is just a variable over here. So P1 does not store the entire object. It does not. It stored what? The address, right? So you know that in the computer memory, it's just going to be a sequence of bytes with some binary address. For example, this can be 00110. I make it up, okay? And then you simply store the address over here, and then you put it here, 00110. Okay, so you can see that we kind of store things indirectly. Rather than storing the whole object over here, rather than doing that, we store the address. Okay, that's really important. Okay, so this leads to the discussion for the next line. This is the most critical line. When we say point P2, apparently we are declaring another point object variable over here, P2. P2 is assigned to P1. What does that really mean? Yes, go ahead. Yes, exactly. You're trying to copy something into somewhere, right? Let's say in the case where, let's review exactly what we did. In the case where you say J is assigned to I, you copy whatever that's in J into I, right? Right, that's what we did before. So now, when you say P2 is assigned to P1, if that's what you say over here, so basically you're declaring P2 over here, and then you're copying P1, which is this value over here, into there, 00110. So now you can see that we still have only one object in the memory, only one, a single object. We have not duplicating the object itself. We are only duplicating the addresses. Okay? So now, conceptually, you can think about P1 is pointing to this object here, and P2 is also pointing to this object here. It's something called aliasing. Okay? So for those of you who actually follow through the tutorial videos for lab number 4, you have seen this already. But it's really important to notice that. Yes? Correct. So you're making exactly correct observation. Aliasing only occurs for the non-primitive type, for reference type. For aliasing, it's really about object addressing, which is only the phenomenon for reference type. By the time of a primitive, no, it's not the case. Right. Okay, now let's see something interesting about aliasing. Okay, let's see something like that. Okay, P1 and P2, and then P1 is equal to P2. Okay, you can just create another one, and then we just duplicate the address again. Let's just try. Okay, what about this? Let's say let me just finish the example here, and then I'll show you another one. Let's say we try to do P3 is assigned to another new point objects. So what do we do over here? Right, let's think about it. Also 2, 3 over here. So now let me just write maybe in green. So we say point over here, P3 is assigned to a new point. Also 2, 3. Okay? Every time you see a new keyword over here, that means allocate another separate portion of the memory and create the objects. In that case, we just allocate another portion of memory over here, which is of the same type, point. And then we also got x and y. In this case, we also got 2 and 3, the same. X and y, 2 and 3. And since this is a separate portion in the memory, so the address is going to be different, right? So let's just, I'll make up some address. 0, 0, 1, 0, 1, for example. Just different address. In that case, when we got P3 over here, P3 is assigned to the address of this new objects. So if I put P3 over here, P3, okay, it's going to store the address over here. So 0, 0, 1, 0, 1. Okay, so conceptually, you can think about P3 is just pointing to a different objects over here. Okay, let's just reproduce. So P1 and P2, they are pointing to the same point objects, and P3 is pointing to just another one. Okay, it's really important for you to trace the program so that you know how things work. Okay, that's something we'll go over in detail next time. But let me just say one more thing. Okay, I want to go over one more small example. Okay, hopefully we can finish earlier today. I hope. Okay, let's try one more example. Okay, so guys, let's assume we have the point class over here. Okay, let's just assume that. Okay, I'm gonna present the following fragment of code to you. Let's see how that's gonna work out. Okay, let's do this. Point P1 is assigned to new point 2, 3. P2 new point 2, 3. Okay. Question number 1. What if I say print line? P1 equals P2. True or false? False. Basically, I'm really comparing if the addresses stored in these two variables are the same. But let's think about, after line number 1, P1 is basically pointing to a point objects over here where x and y are 2 and 3. Okay, after this line here, P2 is pointing to just another new objects, right? Over here. X, y, and 2 and 3. Okay, you can see there's no aliasing just yet. Okay, now I want to show you one thing here. Okay, if I say print line P1.x, we know that at the moment it's going to be 2. Agree? P1.x is going to be 2. Okay? So now, if I do the following, if I say P2 dot x is assigned to 4, okay? And then I will try to say print line again. P1 dot x. I want you to look at these two lines. If I say P2 dot x is assigned to 4, and then print line P1 dot x, would it be 4 or would it be 2? Would be 2. If you look at the diagram, it's very easy. There's a reason for me to set this up. So P2 dot x is assigned to 4. P2 is pointing to this object here. It's going to be 4. So nothing to do with P1. Okay? Let's try to do something here and then repeat the same lines of code and see what happened. Okay? So now let's do the following. Let's say I do P2 is assigned to P1. Okay? Again, this is the most critical line for you to understand. So now, are we trying to copy whatever that's stored in P1 into P2, or copy whatever that's in P1, P2 to P1? P2 to P1 or P1 to P2? P1 to P2, exactly. Now, how should we change the arrow? Should we change to say P1 is now pointing to here? Or the other way? Okay, give you option here, okay? I got two options for you. Option number 1. Just tell me yes or no. Option number 1, I'm going to say P1 is not going to point to here anymore. Instead, P1 is going to point to here. And we have aliasing. Yes? No? Yes? No. Because this line is trying to say, copy whatever that's in P2 into P1. That means P1 is going to point to wherever P2 is pointing to, right? So that's not the way to go. What we should do instead is like this. Oh, sorry. So P2 is not going to point to this object anymore, but P2 is going to point to wherever P1 is pointing to. That's what you would do. Okay? So now, let's repeat exactly these two lines over here. So now we do have aliasing. Because P1 and P2, they're pointing to the same objects. You might have a small question over here. What happened to this object here? This object is not being pointed to by any reference just yet. There's something called garbage collection, which will be done automatically in Java, which you don't have to worry about, okay? In case you have that concern. Okay, after this line here, we know that P1 is pointing to here, P2 is pointing to here. Let's try exactly those two lines. So now P2.x is assigned to 4. And then print line P1.x. You can see these two lines are intentionally the same. Now, we know from before that these before we do the aliasing effects, it's going to print out 2, right? So now what about this line here? Is it going to print out 2 or 4? 2? 4? Well, let's look at the diagram. When you say P2.x, P2 stores the address of this object over here. So when you say P2 dot, we go to this object here and change the x field to be 4. Coincidentally, P1 is pointing to the same objects. So even though you're trying to make the change using P2, but you're really making the change on the same objects. So that's why when you query about P1.x, it's going to be 4. So in this case, it's going to be 4. P1.x will be 4. Yes, so you hear so P1.x and P2.x, they will be both 4. Right? Huh? So you mean P1 and P2? Because they are reference types, so you got aliasing. Yeah. Okay, guys, any question about this example here? Are we okay? Okay, so now I have a challenging exercise for you, apart from lab 6 or lab 5, you haven't finished them yet. Okay, so now I want you to look at, first review this first, and then I have something like here, 2 examples for you. 2.1, without putting this into Android Studio and run it, tell me what the output should be for this fragment of code. Look at that. That's about a primitive type, where there's no aliasing. The second one got something extremely similar, and then I want you to look at what the output should be for this example here. So these are the 2 exercises for you, before I go over the answer with you next Monday. Okay? You can expect this might be something similar to what you'll be given in the exam. Okay? Okay, I'll stop here, and then let me just say something before you go. Lab number 6, you should really start it right away, as I went over the schedule with you. And then for lab number 5, hopefully you have finished them already, I hope. Right? We're going to grade them as soon as we come back in the second week. And for lab test 2, if you really got any trouble with understanding array or loops, you better come to my office hour or go to the TA. Okay? And then if there's any update on the strike, I'll let you know. But at the moment, I don't know. Okay?